In academic research, theoretical concepts frequently stall before reaching the market. Momentum dies in what is known as the Valley of Death. To span this gap, the Indonesian government developed the RIIM competition scheme. It is a bridge built specifically to move research from technology readiness level 3 toward level 6. This functions as a targeted acquisition pipeline. RIIM and LPDP provide capital to secure registered intellectual property and Tier 3 scientific publications. To manage the high output requirements of this pipeline, the government restricts the principal investigator role to individuals with S3 credentials. RIIM competition is a strict procurement mechanism that trades public capital for verifiable scientific novelty. Many researchers struggle with the application because they treat the guidelines as a simple chronological form rather than an engineering problem. We can solve this by reverse engineering the grant, starting at the non-negotiable end-state deliverables. Working backward from those outputs clarifies the rigid financial constraints required to fund them. The final layer of our analysis maps the dual-agency disbursement workflow that handles the actual flow of money. Analyzing the grant backward exposes a solvable, optimized system architecture. Let's break it down. This table defines the baseline requirements: 1 Q3 publication and 1 patent annually. Year 1 requires 1 paper under review. Year 2 demands 1 accepted and another under review. By year 3, accumulation reaches 2 accepted papers and 1 under review. These entries represent an escalating production timeline that places continuous pressure on the principal investigator. All published outputs must also include specific acknowledgement language citing both RIIM and LPDP as the funding sources. Failing to meet these year-over-year publishing milestones results in a severed research contract. Before research begins, the system applies human capital constraints. A principal investigator can lead only 1 proposal per year and join a maximum of 2 others as a member. 3 distinct tracks feed into the RIIM pipeline. The internal track is for existing RIIM researchers. The external track is open to academic institutions, NGOs, and private R&D teams. The alumni track targets S3 graduates from the last 5 years. Graduates returning from overseas have exactly 3 months from proposal acceptance to secure a domestic institutional affiliation. Regardless of the researcher's entry point, every single approved proposal enters the exact same rigid performance and financial pipeline. The high output expectations are set against draconian restrictions on how funds can be spent. The Rencana Anggaran Biaya, or RAB, is governed by negative constraints, a list of expressly forbidden expenditures. The grant provides 0 funds for researcher honorariums and 0 funds for academic publication fees. Foreign travel, the purchase of communication devices, and data plans are also prohibited. Permitted spending covers only expendable materials, specialized lab rentals, transport for fieldwork, and third-party testing services. Capital expenditures, such as hardware, are capped at 10% of the total approved budget. Costs for institutional monitoring and evaluation are further restricted to 5% of budget, with a hard cap of 5 million rupiah. Ultimately, the RAB functions as a lean fuel mixture, designed strictly to support prototype generation and IP registration. Securing the grant is only the first step. Capital disbursement requires navigating the bureaucracy of 2 separate agencies. The principal investigator first uploads the proposal to RIIM for verification and contract drafting. Once the contract is finalized, the data is transferred to LPDP's ERIS Pro system. A specific financial threshold dictates how the capital is released. If year 1 funding is 250 million rupiah or less, the money is disbursed in 1 stage. Funding that exceeds that amount is split into 2 tranches of 50% each. Unlocking that second tranche requires specific proof of progress. The researcher must submit an audited report proving 80% absorption of the initial funds. They must also provide a progress report validating that they are on track to meet their publication and patent indicators. Ultimately, continuous cash flow throughout the grant lifecycle depends entirely on proving high operational velocity and strict, non-negotiable administrative compliance. The entire RIIM architecture functions as a system that takes doctoral-led inputs and passes them through rigorous filters to produce intellectual property. RIIM competition functions as an aggressive, milestone-gated factory for intellectual property. Success requires a data management plan that aligns perfectly with the compounding output timeline. The budget must be self-censored to ensure no prohibited items trigger a rejection from the PMO. Pacing is critical. Laboratories must execute quickly enough to ensure a paper reaches under review status before the year 1 deadline. Mastering the logic of this architecture allows a principal investigator to navigate the system with precision. By treating the grant as an engineering problem, researchers can secure the capital necessary to push Indonesian innovation across the Valley of Death.